Okay, checking my audio. 1, 2, 3. Okay, seems okay. So we're gonna get started, and I've got an Emacs, new fresh Emacs buff, window up, which means it's not ready to use. Here we go. We'll be in the VV project. So let's take a look at our journal. See what we were doing last time. Then we'll look at our to-do list. Okay. I did not actually update the journal version last week, did I? Good heavens. Probably because I didn't have a strong plan going into that session. Generate DFAStates as methods. I think that's about where we got to. Test compilation of the various performance switches. We don't expect anything to actually work just yet, but you know, did get that far. So let's see, where are we in the other thing we want is the performance switches there. Okay. So intent and the defines. I think that's a good way to break this up. Maybe just description. Okay. Okay, let's add some quick descriptions here. Okay. Can open and read files using different methods. Maybe consider adding memory map as an option. In theory, that's one of the fastest ways to get a file into memory. Iteration. The consistent text buff. Let's see here. Iteration through a text buff can be done just using a char ref. Or we could wrap it up in an iterator so we can use what's it called, for each loops. Okay. Oh, I'm so tired today. Navigating to the next DFA state can be done in different ways. Switch array of function pointers or go tos and labels. There we go. Token processing. Processing tokens could be done all in one call and filled into a vector. Into a container. I don't know what container I want to use yet. Or tokens can be produced lazily, one at a time, when requested by another component. I need better words. Like I use the word component for like UI components, but then process can mean like different threads or different running executables on your machine, another feature, another when requested, I guess. I don't have to know the details. Words can be a little tricky and ambiguous or overloaded sometimes. For functions in the tokenizer could be methods or macros. Implement. Yeah. So for each of these, I want to note should be transparent to the compiler. So which one we choose doesn't matter. Same here. DFAState dispatch really should be transparent to the compiler that we're building. Token processing, this will not be transparent to the compiler. You have to wire it up a little bit differently, depending on which process you use. Helper functions will be transparent. So maybe that's fine. Hey JTL, how's it going today? It is a good day. It is a good day. Getting warmed up for the day. How are you doing? You got your web page built up and your legal docs all reviewed and ready to go, or are you still enjoying a little bit of time off this week? Got back from a nice bike ride. Almost done with the web pages. Good. Oh, yep. CSS. The idea was to separate the display from the content. And then you almost always end up having them so tightly tied together, it's almost impossible to figure out what the problem is. So, fun times. Fun times. Well, oh man. I don't know why I went to bed reasonably on time last night, but I'm just dragging a little bit. Well, good. It's also good that you can get in a bike ride, get things warmed up and moving before the day starts. I think it's a way better way to start the day. A little more time off next week to go camping. Oh, okay. How about the trail if you're interested? Okay. Yes. That sounds good. Lily was just asking if the backpacking trip was canceled. So Thursday, Friday, Saturday. No, I do want to go. I want to sit quietly and whittle, and maybe read a book. Sounds great. Okay. Well, I'll raise the subject to the parties at home Twitch It Matters. Sounds good. Okay. So, I think our to-do I don't remember what this task is. This is the problem when I only work on a thing once a week. So let's take a look at that. This one goes into our journal. $2024. Oh, 9. That's the 20th. Oh my goodness. Okay, we talked about several different methods for performance comparison. Starfleet notice can't ever predict our future right in front of the advance over here. Yep, I know how it goes. I do wonder how much of that is my own fault though. Like I run into the same issue. It's like I planned something, then something else comes up. But like if I just always defended what I'd scheduled, maybe it wouldn't be a problem. Maybe it's a problem only because I let other people set my future, my schedule. I don't know. There must be some people in this world who don't have that same scheduling problem. Okay, so several different methods for performance comparison. We're gonna just start writing them out here real quick. Iterator based advancement. Let's see here. Character advancement, iterator advancement, or character advancement. Yeah, I need schedule assertiveness training. Probably more useful than a lot of the trainings I've had at jobs. Iterator or just a plain old bare char ref. So that's one. Okay. DFAState dispatch. A switch statement. Function pointer array. We're going to spend a good amount of time in this area of the code, so go to and label. Oh yeah, I forgot about this one. Just a function pointer. We could do that. Token processing batch and lazy. The helper functions are already kind of in there that way. Okay, so these are basically the high-level things we want to build the same code for, the same functionality for in the two different ways. Actually, for those that have watched the structure and interpretation of computer programming lectures, there's a whole couple of lectures within there where they talk about function dispatch. So lots of different ways to do it. Okay. Dum dum da dum. Okay, so what are we going to do today? We are going to batch iterator switch statement, I think, is the plan. Batch processing is just going to be more straightforward. The switch statement should be pretty easy to implement as a first option. Okay. So if we get these three things done, we will have a working tokenizer generator that only does a teeny fraction of the things I want it to do. But this is kind of like step one. Okay. So I think that's the plan. So let's go see if I can remember what this was about. I copied this text out of a file somewhere. Was it in like code snippets? Would be in the tokenizer. Nope, not there. Really? Oh, I did. I did do it already. Yeah, the start state ID is. If we go to the source, the test, VV test, there we go. Next state equals that. Okay, it worked. Okay. Object parser. No, not that one. Okay, there we go. DFAStates. Good afternoon, and how are you today? I'm doing great. It is a good day. How are you doing? How's everybody's plans for the weekend? So technically we did that at the end of the last stream. I just didn't have it marked and updated. Weekend plans low key. Oh, fun. Fun, fun. The band is playing. Good, good. Is it an outdoor venue or an indoor venue? Okay, good, good. Yeah, we're heading into time of year where the weather is a little bit more dicey, but you should have okay weather tomorrow. Good. You guys have only had what, 3, 4 gigs this summer. That's doing very well. Some back end dev this evening. Plans for the weekend, going out in the nice weather. Probably do some coding. I do try to keep the weekends off the coding, but more just so my family sees me once in a while. Afraid coding is too easy, too exciting, too you can get sucked in real easy. So I gotta watch the kids for a while on Saturday, anyways. My wife's got things going on, so I can't code when I'm watching the little kids. The older kids, sometimes I get away with it. Okay, good. Sounds like everybody's got some good plans. I am doing some steaks on the grill tonight, so that's nice. I really don't have anything else planned. Maybe I'll do a little bit of woodworking in my shop. Although I'm watching the small kids, so that's still kind of an issue. We'll see. We'll see what I get around to. I know what I do need to do. I need to file this business registration and get that rolling. I think I've settled on the name. The URL is available that I've got planned. So it's all about just getting that ball rolling. So maybe I'll do that. That's the kind of thing I can do while I'm watching kids. Filling out forms. You can always step away from them and come back. Okay. So token processing, we're gonna do it batch. This is kind of won't really know if it's working until all 3 pieces are up and running. Like it's one of those things where all the pieces got to be in. So we're going to be manually inspecting the code, but we won't be able to run it very well. Okay, so what we have to look at is our VB test parser. What we have is down here. Whoa. And actually, let's see here. I said dispatch switch, dispatch lookup. Oh, is that what I'm calling it? There we go. Function pointer array or function pointer. So basically, unless we're using gotos, we have to define the actual methods as functions. So that's my plan. So just to recap, eventually we're going to code it up so that every set of options for performance we can turn on or off with a define statement and then measure. But until then, all we need to do is make sure that it works, and we won't worry about timing until we have the functionality built up to actually do the comparisons. So today, the plan is we're going to work on batch processing our tokens. So we're just going to accumulate them in a thing. It's going to be a single function call, and then here's the array of stuff, the array of tokens. We're going to walk through our text buffer using an iterator. So just a good old for each loop. We don't have to. We have a different method, which is basically index-based for loop kind of notion. It's a little more complicated than that, but that's the idea. Just so that we can measure the overhead of an iterator. And then we're going to dispatch our DFAStates using a switch statement today. If we get all that done, we might have a working tokenizer by the end of the day. So I think this is where we're at. So here's our helper functions. And here's our actual functions. Okay. Okay, so we're ignoring process lazy. We're not touching it. In here. We've actually already tested both of these. Yeah, everything in lazy is going to be a little bit different, so I guess so we're going to say process things and then give us the results. So do I define a set of tokens? I do not, but we can put that inside of context. That's probably the best place for it. So what we want is a bunch of tokens in our context. Message counts, etc. Okay. Okay, so here's the thing. This can only happen if we're doing batch processing. So pound if def process batch. Add token. I do want it to fail if I accidentally build without implementing something here. So many different ways we could do this. Like a vector of token. Okay, well, m_tokens clear is easy enough. Add token m_tokens push back the token. And the last thing we want is to get the tokens out return m_tokens, but it has to be const, so you can't modify it, and we pass a reference, so there's no explicit copy made unless we do weird things with the tokens that we get. So basically, these are our modifiers for the tokens. Then we can get a constant reference to the actual data. That seems good. So, in performance switches, in DB project, go in Tokenizer. Do more stuff here. Yeah, for in batch. Context.clear tokens, just in case we get a context to add something in it. Start tokens. We start marching our way through the characters. And then we dispatch. So for each state ID, we need a way to know where to go. So I'm thinking if, let's see, where is it? There's the big long one somewhere. Where did it go? Did I make changes to this thing? I did. Shame on me. Shame, shame, shame. DB project parser. The tokenizer. Wait a minute. Okay, so at the end of this, okay, so that's going to fix that. Which probably means VV project, which was writing those things. Found if defined, yeah. See, that goes away. That's always the same. So basically, this function, when we're going through here, we hit that dot, 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 and we stop outputting this snippet. We output this stuff. Then we output this next chunk. So let's have a whole code file so I can see the framework of all the pieces in one place, but it is broken up into dot, dot, dot regions or chunks. So, so in here, we do that, blah, 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 doesn't matter. VV project parser. So this is the generated file, VV test parser. VV proj parser is what this was generated from in combination with all the other pieces. So this is a part of what ended up in VV test parser. It lets me think of this as a file, even though it's going to be dumped into a longer file later. Okay, so we got clear tokens, start a new token, and then do things. we do not need this function because it's in the context, which is good. So except wherever we do an except, we need to say underscore context dot push back or dot add token some token. So we're gonna have to come back to that. In fact, that's one of the to-dos we'll have to do. What's in token? This has line, character in line, and a okay, so token. I'm thinking what I want is to actually use the token inside the tokenizer itself as bookkeeping. What if we do this? We do not expose any constructors for tokens in the public facing interface. And this is a friend of the tokenizer class. This is fine. We're going to do that. We probably do need copy constructors, etc. Or at least the vector operations. Let's go stub these out real quick. Okay, underscore line equals 0. Character in line equals 0. Underscore ID equals 0. Or where's token ID? I don't think I put it in error anywhere. Let's take a look at that real quick. Oh, we did already output the state IDs. Good to know. Last token. Oh, because that's in the header. So anyone implementing anything would need this list. So I do not have an error ID. No, let's not do it that way. take that out. We probably do need copy and assignment operations. Well, that's not really that hard. So token.cp. And we just do that. Okay, so m underscore text equals other dot m underscore text. M underscore line equals other dot m underscore line underscore line underscore character in line equals other dot m underscore character in line. MID equals other dot MID. Easy. Then return a constant reference to this thing. Okay. Content of this equals other. Basically, this uses this thing. And done. I think we'll need those for the vector operations. Which means we only really need this if we're batch processing. No, that's not true. When we return the token, we probably want to give them these options as well. Well, is that even true? We might. Okay. So that's good. Where are we going from here? Something we'll need to add into our to-do list somewhere. Text buffer track lines as refs. Okay. So later on we might need to say, hey, we have an error on line 13, print out line 13. So that'll be part of line processing eventually. So except I need to keep track of whether I'm in the generated file or the source file here. So except what's the tokenizer care about? Okay. Ooh, interesting. Let's take a look here. C++ preprocessor if inside macro definition. Can I do that? Well, Stack Overflow has a question about that. Closed 12 years ago. You cannot do that. So we have to do it the other way around. something about a token. So if we're generating helper macros, if we're doing process batch, then we define accept this way, otherwise we define accept some other way. And of course, we can't use those here, which is the same problem here. I do wish the auto formatter was a little bit better about not fighting me. Time for some coffee. Yep. Keep your fluids up. Okay. This whole area is just going to become very, very messy in a little while. Because this next state is going to behave differently in the 4 different cases. Okay. Okay. Well, hopefully this is okay. Okay. Looking for so. All right. It's going to equal. Oh. It's going to equal start state method. Let's put that back the way it was. If defined, what did we call the other one? dispatch. No. These are dispatch. DFA dispatch. Okay, so we're not being very consistent right here, are we? Hey, Pat, what's up? We are generating code which in theory should let us batch process using a for loop all the tokens using switch dispatching for the DFAStates. In theory. So that's very exciting. Could move, yeah. Like this one, just setting the next state is that kind of logic. This is in accept. The state goes back to the start state. Correct. Process. This is like the pre-startup warm-up thing, so that's fine. Then it goes to the start state. And begin. Yeah, this is gonna get complicated. We started the AI Wordle game yesterday with proper prompting and used the new ChatGPT model. I'm going to send you things nice. Kind of impressed with not having to lift a finger of actual coding for this one. Didn't look at the code base in depth though, so I'm sure it's a mess in some ways. Yeah, that's always interesting. Cool. Looking forward to seeing it in action. The other thing we need to do in our Makefile. I said we're starting with batch for each helper functions and dash D DFA dispatch. We're going to use a switch to get started. So yeah, each of these could be one of 2 or 4 things. So it's like, I did the math once, it's like 96 combinations of ways we can generate our code. Maybe it's worse than that, I don't know. Okay, so if we say dispatch switch, if DFA dispatch switch we have switch, we have function, pointer array. We have the bare function pointer option. Then we have the go-to option. Okay, look, such a zip in the folder, include the 4 DLLs used to build it, so it should work. Nice. Okay, cool. I will take a look at that after stream. I only get 1 day of compilers a week, so I gotta use my time here. But still, not a single finger lifted to make it change, huh? Did you play it? Did you win? Dot. Inhale something. Man. Huh. Okay, cool. I think the AIs are getting better and better at small coding problems. It's the big ones that are. It doesn't understand this system. I had to fix a few subtle errors, but it did actual proper things. Okay. Oh wow, scenes in a state system? Nice. So, you spend a lot of time crafting prompts. What's the most surprising thing you had to add to a prompt to make it work right? Like, I had to prompt the AI to construct a file in a certain format based on a paper I fed it. Took an hour of prompting until I could reproduce the file. Okay. So some of the things that humans take totally for granted. Okay, so Tokenizer now comes in multiple chunks. So the switch statement. Comes in before this chunk. Write out these enumeration. Nice. Yeah, that start state ID is going to be a problem because we need to pass in a lot more than that. Just that. Okay. It's supposed to be chunk 3. And in here, right switch. Let's see here. DFA switch dispatcher. and then a blank line. So in Tokenizer, okay. It's good at being taught things in the moment if you word it correctly, I suppose. Yeah. I keep telling people that AI is just doing things that humans can do slightly faster. It's not doing things better than humans by far. Yeah. Now, granted, like, sometimes it amazes me how simple instructions escape my children. It's like, wow, an AI could have done that so much better, because at least it would have done what I told it to do, even if it's wrong. But yeah, it's not smarter than humans yet. Most humans. Okay, so switch statement. Well, let's see, what are the things we need? We need backtick. Start state ID is a thing. Start state ID, start state method, and label. Those are the other things we need eventually. We're just going to fake it for now. Okay. In theory, we re-embed our snippets, it generates a bunch of stuff. I did not declare that function, I agree. Okay. Not too shabby. Right, token methods. Okay. Been testing with SNES assembly, and if you feed it the documentation of the 65816, it can solve simple issues at least. Yeah. Cool. I guess I'm not surprised that there's probably enough code on GitHub that are SNES assembly. The SNES has a certain nostalgia value. Okay. So we have a switch statement in Tokenizer that we need to fill up. And it's at a depth of 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. That's here. Exactly 16, so it's a depth of 4. Okay. Token. Emit DFAState, emit the transitions. Where's the enumeration? State ID enumeration. Basically need to grab this. It's very similar in nature. DFAState. Alright, where do I put dispatch? There we go. So we get our DFA, we get our DFAStates, we walk through them. Instead of writing this, we write case the thing then we're going to call a thing and then break. And what this thing is probably, so this is the method name. So write token methods, we do generate this here. This is our method. Is there a reason I passed on this character reference? I guess it's fine. It's fine. I think that's basically it, actually, for the switch dispatch. All right, let's see how it works. One thing I did that was cool, so the AI did for the Wordle game, was the fading scene transitions without you having to ask it to do that. Wow, that's actually impressive. That must be a very common pattern with modern game engines, that you fade in and out of scenes. Cool. Does this thinking process where it just feeds back to itself text that it's saying to make sure it stays coherent to the prompt. Oh, so it's basically feedbacking into itself to make sure that it's introspecting its own response. Interesting. I can't, yeah, that's probably helpful. Don't know that I would have thought to try that. Oh, so we did the thing. So let's see, VB test parser. Okay, so we change anything here. There's a token. Private, whatever. Okay, well that still looks, oh. I thought I made the token. did. So where did those two methods go? Oh. Okay, we need to compile test. There we go. Oh, okay, there's our problems. I thought that was a little bit too clean. We weren't actually running the full build and test. Okay, so we get our DFA, blah, blah, blah. Oh, interesting. Go to function pointer array, dispatch switch. Huh. Okay, I've got either my chunk numbers messed up or something. Doing it in any of these three methods, we just generate the functions. Yeah, I broke something. Where the text does not line up. Just switch those two chunks. It's this thing. This is a terrible name. DFAState methods. Way better. Okay, that's more sense. Trust enum method and label. Okay, so we're doing this thing. Kind of need to do that for this method. A label. DFA root status, this thing. And the label is actually easy. This is just DFA root state. I'll just do it. That's fine. Okay, so that should help a little bit. I look at Tokenizer, chunk 1, then we emit state IDs. So Tokenizer CPP1, write out the state IDs. I'm gonna put a bunch of junk. Until we're in the switch dispatch. State ID, then a bunch of stuff. Then the dispatch. Then we output the actual methods. Okay, we'll try that. Then we just have the two chunks swapped. Unused variable last state. We don't need it as much in this case. Get all a one-liner. Perfect. Okay. Straight backtick. Oh dear. Tokenizer, getting an enumeration of all the states, which is fine. Helper macros process batch. So at the end of helper macros, oh no. Batch. Oh, that's out. So that ends the process batch one. Start new token, end of those. Okay. If we're lazy, we do these things, which we do not. What I really want to get to is when we're running all these different combinations and tests for performance. we settle on the ones we want, and then we can literally prune through everything that isn't the fastest. Our code will shrink so much in that day. So if process batch, take our process function. There's our switch statement. Look at that, not bad. Okay. This line here is unmatched. Context.add token. It's helper macros. Process the batch. If def. Okay, so something else is mismatched. Shoot. Just a moment. I'm not sure anybody's home. my kids. Oh, my kids. All right. So let me write down a note. To the fair with some friends, but the one kid didn't bring the right like ticket purchase proof or something. I don't know. Tell my wife, who is not in the house right now. Which I will leave somewhere clever. That captures the most of the details. I gotta go drop this off somewhere where my wife will find it. Then I shall return shortly. You're back. JTL, I suppose a feedback loop is an AI improvement. Well, that's how you train AI, so I guess it's more of a redundancy check than anything. Here's how the industry will deal with temporal degradation. Seems a foreseeable future AI needs a healthy supply of ingestible data that does not come from AI. What? No audio? No audio. No audio. All right, checking audio. 1, 2, 3. Oh, no audio for himself. Okay, yeah, because I just checked it. It's coming through the Twitch web page okay for me, so. Okay. Yeah, the problem is AIs are going to start consuming content that was generated by AIs because everybody's trying to replace real content with AI content. Yeah, JTL, I think it's you this time. 99% of the time I'd be sitting here trying to figure out what cable I unplugged or something, but helper, batch, helper. Okay, I'm happy with that. Lazy, those two go away. Function pointer goes away. Dispatch goes to go2 goes away. Lazy goes away. So that's a 0 there. That's fine. If process batch, if we define these two things, fine. If it's that thing or that thing, we're inside batch. So text for each goes away. Interesting that text for goes away. Dispatch switch. Dispatch function pointer array comes and goes. Comes and goes, comes and goes. End of batch. If helper function, define batch. So helper batch. Batch goes away. If it's find these things, and if helper macros, and if. Alright, something's not mismatched. So yeah, JTL, hopefully you can hear. I don't think it's me. Pound if def. Okay, so we're not adding any there. Pound and if. No. Right. Try this again. Okay, blah blah blah. Bunch of errors. Oh. Just a minute. Okay, I'm back again. Okay, so I wonder. Start state ID. Loose. So which chunk is that in? Okay, that's the problem. We got our chunks misaligned. Maybe when I think I'm in chunk 1, I'm really in a different one. This is done in the helper functions. So it's here. which is in chunk 2 or 3. Is chunk 1 doesn't have any replacements. Chunk 2 does. Chunk 3 must. Yep. And chunk 4 does not. Okay, so BP project. Write out chunk 2 and 3, and then it writes out chunk 3 again. This is chunk 4 now. That should fix many issues. Had to reboot. That sucks. I hate rebooting. I try to avoid it as much as I can, unless Windows absolutely makes me do it. It's a pointer, so okay. We probably need to scope those. So in VB project, switch. State ID. Okay. Okay, oops. Yeah, no, this is dot. So the thing that's calling clear tokens. This is a pointer. There we go. Okay. And actually, that probably needs to go in begin. Oops. VB test parser. Okay. Token rule ID was not declared. Okay. Generated character reference doesn't have the comparisons we need, so that's fine. We can fix that. Token rule ID. I can swear we had the overloads for these. Okay, so a lot of these are just repeats of the same errors over and over again. It doesn't have character comparisons or integer comparisons. Use parameter C. I guess that's possible. I'm not sure why I'm passing a character. So let's actually go change that. Why not? Why not? Let's go change it. So in VB project, we're not using C. We want current. Yeah, that should be it. Okay. Now, let's go look at charref. In assets, code snippet, character, reference, UTF-8. Operator, assignment equals other equals a number. Solution cast two integers. Not any problems with those. We do not have less than or greater than. So one part of me says only generate the bare minimum of what I need. Like the bare minimum. One of them is once you start generating all the greater than less than comparisons, you kind of have to do it for all of them. But what we basically have here is we check between values. So are we less than or equal to other? C dot value less than or equal to other, except it's the other way around. Let's just generate what we absolutely need. Let's not overthink it. Hopefully that gets rid of the bulk of those comparisons. Yeah. Forbids comparison between a pointer and integer. What? Non-number function. Oh, can't be constant. Okay, that makes sense. So character reference for this thing. This cannot be const. This is not. Other is not a pointer. C is not a pointer. Character pointer value? Oh, that's as a string. Shoot. So what we really need then is a int 32t UTF-8 code point, not code point. UTF-8. Oof, where am I using value here? stir value const. Oops. Can we make it a friend? Is that a thing? Maybe that would be better. No, we should just give the value. Should we break other things? So this one, this one is that thing. This one is for string reference, so that's fine. You know what? Yeah. C-stir. I have to go look at all the other character references. I'm pretty sure they're all fine. Well, we'll come back around to those if we need to. Okay, so let's open string ref. Just call it C string. ASCII. Let's be consistent here. String ref for Latin. C string. Okay. Okay. This is a problem with writing code which writes code, and if I just chose one code path of decisions to make, it would be a lot easier, but I want to compare the performances of everything. Okay, so cases now, BB project. That's exactly what I was afraid of. M_current. Boom. Now we don't pass anything. And actually, in the tokenizer, let's go to our next state. Oh, so that does just dispatch correctly. Okay, good. BB test person. Here we go. Token rule IDs. It might just be a simple name change that I need to make. Okay, so that's what we're calling it here. Okay. Rule ID. Current rule ID, I think that's... There's the rule ID and the token ID. Rule ID, rule ID. Rule ID. We're only keeping track of the rule ID. Okay, that's all the easy ones. Now, declared private here. Okay. Okay. Tokens pushback token. All right, copy constructor and assignment. We'll put it up here somewhere. Oh, shockingly, that worked. So let's look at our new. Oh no! Did I close the whole window? Size for streaming, VB source, VB test parser. Okay. All right, journal. To do performance switches. There we go. Okay, what else do we need? Test parser. Okay, so what we've got is our mostly changes in our tokenizer. Right here. We construct an empty tokenizer. We set the context. We declare the states that we're going to use and give them a number. Blah, blah, blah. Okay, so here, if we're batch processing, we have the process, which clears out the tokens, zeroes out some stuff, sets our first state. Then we're using the for each, so we go for each character in the buffer, capture that in the current. And for each state, we get the function that we're going to process that character with. And then we declare the functions here. Munch. Error. Or yeah, we're not doing errors yet. Munch. Accept. So munch is a little bit of an interesting concept, actually. Even in this context. Okay, accept, etc., etc. Next state, current rule ID. Okay, so this for loop here. Sometimes we want to take a character, process it, and we don't want to move on. Sometimes we do want to move on. So this for loop actually needs to change a bit. If we're using for each. Well, we don't use a for each, we use an iterator. If there's a way, let's hear Emacs. Set defines for C macros. Hide if def. So there is a way to hide if defs. Okay. Hide if def environment. Take that H file and hide it. We'll extract all pound defines. Okay, so it looks like there might be a way for me to show and hide these pound if def sections. In Emacs. There's a file, yeah, so I'm not gonna do that on stream, but that is something I might want to do over the weekend so that I can set it up to work in a particular, actually, just do it. Do we just do it? We just do it. All right, so here's what I'm looking at. There's apparently a hide if def file for Emacs, which we can download. And I'm going to put it in a special Emacs directory for myself, which is where? Somewhere. I have like an Emacs folder. Okay. then we're going to look and see if it tells me how to use it itself. Hmm. Load file, idfl, h if compressed to finalized. They really did not give very good instructions on how to hide if def define. Okay. So if I go to VV test parser, I can say DFA dispatch function pointer to 0. Did it do anything? I'm confused. Hide if defs. Because that hit all the if defs. Is it 1 or nil? Is that the rule? LIO F string nil. Oh, good heavens. Alright, well, I clearly don't know how this works yet. So. Nil1, define a list. Lambda hide if def mode -1, not good. Hide if start -1 and +1. HIF defined 1 or 0. Okay. So if I say fstream 0. Nope. Okay. I have no idea how to make that work. I really thought that would help, but it doesn't apparently. So here we go. Need to go, Travest. Have a wonderful weekend. Thanks for dropping in. You ever looked at Soding's C library for putting pixels into memory in an array? I did see that. Gosh, it's been a while. Yeah, he actually had, like, he had it wired up to do WebAssembly or OpenGL or, like, on a console, was it? Yeah, it's pretty crazy. Write your pixels, then it'll display in all kinds of weird places. I did see that one. Soding does some bizarre things sometimes. It's kind of fun to watch. Okay. So what was I even looking for? Okay. Here. This is all fine. Oh yeah. The for each. We can't actually do this because Munch may or may not consume a nice character. So when we say Munch, if we're using an iterator, it needs to do something different. Which I kind of don't like, but what can we do? So go to our tokenizer definition. Reduce equal things. Yeah, okay. Here. So if we're doing for each, we need a text buffer iterator and end. Yeah, it's pretty cross-platform because of what it does. Yep, it just dumps stuff to memory. It doesn't know what the memory does, what it means, or who cares. See, and to some degree, I kind of like that. Like, well, like binary executables, right? Why does my executable not run on Linux the same way it does on Windows? It's still x86, 64, Intel binary code, right? Or AMD. It should run the same on both machines. But no, the operating system built on top of it says, you know, you compiled this in Ubuntu, therefore it won't run in this other thing. It's like, well, but it's the same memory, literally. It's literally the same executable binaries, and that makes me mad. So yeah, the way that Soding built that was pretty cool. Very interesting character, that fella. He's from Russia, I believe. equals underscore context buffer begin underscore end equals the same thing. While iterator not equal to end equals the contents of underscore iter, and now advance munch oof. Yeah, this complicates stuff more. If def text for each here, when we punch, we say, oops, not that one. M iter plus plus iter not equal to M end current. You know what? M current just equals contents of underscore iter. Is that correct? Not sure we need to even do this line. In all but the go-tos, so we're just gonna skip that. Munch. Munch. This munch. If def text for each here's what munch looks like. We'll choose the 4. I think, yeah, over the weekend I'm going to take a look at that script and see if I can. Yeah, same little good old Russian. Yep. Okay. Oops, okay, yeah. Do this in the right directory, so the right file is invoked. Yeah, he's more willing to use things like JavaScript and whatnot than I am. It's not actually built. Oh, cool. Here, maybe test parser. Much. Did I update in the wrong file? Just a second. Okay. I think I edited in the wrong file. What we really wanted was Tokenizer Munch. Oh, there it is. So I did do the changes in our file. That's good. This thing, Munch. Oh yeah. I forgot. Okay. Oh, we're back to doing silly things. One of my text for eaches is not. It's not ended. Yep, you're right. Okay. What language are you making? We are not yet to the language part, but it will be a toy language of my own design to explore some ideas about looping constructs and, yeah, mostly looping constructs that I have interesting thoughts about. I have a name for it, but I mean, we're far enough away from that, it doesn't matter. This is Compiler Friday. Monday through Thursday, I work on a game. So the compiler work is moving very slowly, and we're not doing it in like an optimal way. We're writing a tokenizer generator, not a tokenizer. So like that's usually not the best place for people to start making a compiler, but this is the kind of problem that interests me. So we're doing it my way. And worse than that, every time I think that there's 2 or 3 different ways to do a process, we're writing a pound define and implementing it both ways, so that at the end of the project, they all will work, and we'll be able to do performance comparison to see what each of these ideas, how much it costs. So we are really not optimizing developer time. This is my palate cleanser, I guess. I work on game Monday through Thursday, then I do this for fun. So it's going to be a long time before we get down to revealing the name of my programming language and starting on it. Long ways. So if you want to write your own compiler, I definitely say start with your own tokenizer. It's dead simple. It's a for loop over the characters with, some. All you do is check what character you got and jump to the right place. So yes, compilers are cool. They're interesting. Always happy to talk about them. So if you want to do questions about compiler structures or what you could do or what I'm doing, go ahead and pop in the chat and throw them out there. I'm more than willing to take detours. Sometimes it brings up good ideas. Sometimes it's just good information for people. If it's over my head, I'll let you know. I'm not going to make something up. And then, otherwise I just stream stream of consciousness while I code. And we're just kind of building a compiler in all the wrong ways, but it's the kinds of ways that I find fun. Because nobody's paying me for this, so my time is not worth money right now. Yeah, no, make your own compiler. It is an interesting process. It was one of my favorite college classes. I've built several compilers and interpreters and data file processing. It's all been that's some of the more fun projects I've worked on. So welcome aboard. Feel free to join in. Let me plug my thing here. I should probably write a bot one of these days. I have a Discord channel if you want to get notifications when I stream, but honestly, it's Monday through Thursday, and it's game day, no engine, and then Friday is compiler day. That's like a mini rest day. I always start 12 o'clock West Coast United States time. So what is that? LA time zone. Yeah, so welcome aboard. Give a follow. Old videos are on YouTube and Rumble, which you can find those links on my About page tab in Twitch. So you can go back and watch all the compiler videos. there's a lot more cheating on that one. Like I've sort of sandboxed a lot of these things before, so I can copy paste large chunks of code. So they might not be the best videos, but you can see I do show every line of code that we write and talk about it. So hopefully you find this entertaining or educational or something. So where was I? Finding our errors. So the tokenizer takes in a data file with basically the regular expression pattern. What should I do with the token when I finish it? And like a label, right? And so we read that in, and then we're going to generate a file which writes out the way to process it as a DFA, discrete, a deterministic finite automata. There we go. And so we're writing code that writes code that reads code to generate code. So it gets a little bit mind bendy. So if I get lost like fiddling around with this kind of thing right here, yep, that's kind of the way it goes. Yeah, feel free to ask questions. I'm happy to overview compilers or tokenizers or tokenizer generators, or go completely off topics about programming in general. We've had political discussions, philosophical discussions, all sorts of stuff. Whatever you want. Where am I? Yeah, maybe. Where did Savage Lord Severus go? He's not here today. He's written his own Twitch bot. I maybe should write a Twitch bot. I should just fire off once in a while and put my Discord in the channel. That kind of thing. When? Okay, so maybe this is my problem here. Assets, code snippets, a text buffer, iterator. I guess I can create an empty iterator. That's fine. It's a little silly. It just doesn't do anything though. But then we assign it, which that is an operation we allow. Oh, it's not. Huh. So when we say begin, and end, there's the equals. Okay. So that should fix that issue. Oh, it worked. That was it. Okay, so let's take a look at VD test parser. Reload it. Find our class tokenizer. So architecture-wise, there's a lot of different pieces here. There's a text buffer which opens files or references text that you hand in, and that can, depending on what your choices are for your project. So let's see, test VB project. So you can set an encoding. We support UTF-8, ASCII, and Latin 1 encodings. So that's generated into this file. There's two files generated. This one so far only exposes token, because that's all you really need to see for now. This one implements all the stuff we need. So we've got a text buffer implementation, which don't even want to talk about that. But here's a character reference, which doesn't copy any text. It points to the text buffer. Okay, so we're not going to copy any strings. There's going to be no string copying in this program, as far as our side of things goes. But a character reference points to a location in the buffer. And it does check the UTF-8 bytes. So if you want to talk UTF-8 encoding, I'm happy to walk you through it. Then a string reference is kind of the same thing, except instead of one string, it can be more than one string. So you can construct it from 2 characters and say from here to here is a string, because that'll be what we pass around in our tokens, right? So again, no string copying, just a bunch of integers, done. And by a bunch of integers, like this is not much more integers than you would use anyways, plus a string. Then the text buffer gives us an iterator. So we can walk through one character at a time. The context is basically, here's all the stuff we need through the first 2 stages of our pipeline. It's going to be all the intermediate results, all of the shared results between the different stages. It's all going in here. So things like error messages, right? They're here. So whenever we give the tokenizer this context and say, here's the text buffer, and then we pass this into the context goes to the tokenizer, and the tokenizer says, okay, I know where the text buffer is now, and I know how to report errors into this thing. And then we're going to store a list of the tokens as we go in the context, because that'll then be passed to the parser. Blah, 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 a couple of convenience methods, etc., etc. There's the token. This is the thing that the user actually gets at the end of the tokenization phase. Then yeah, the tokenizer class itself is going to be a little bit terrible just because we have so many different methods to do things. So we're going to iterate through our text in 2 different ways. We're going to dispatch our DFAState processing 4 different ways. We're going to process all the tokens at once and give you a list, or we're going to do it lazy and just hand you a token when you ask for one. And then we're going to have our helper functions inside of our tokenizer implemented in 2 different ways. Once as macros and once as actual methods. So this is, and I did the math once, so let me do it again real quick. Let's go scientific mode, and we're going to go, we have 3 modes here for how we open and read a file, times 2 methods for the 2 different ways that we go through our text files, times 4 methods for how we dispatch our DFAStates, and 2 methods for that one for processing, and times 2 more for our helper function definitions. Now, the reason I'm doing this, at least in part, is because I want to know how much it costs, right? Everybody has little, nuggets of wisdom to tell you about how to optimize things, but they're almost always wrong, or wrong about how much it matters. So I want to actually measure it in a full system. So I'm going to implement the system in 96 combinatoric ways. And there we go. How do you jump to org from source? So, I don't know how familiar you are with Emacs, so I'm a little unsure of the context of the question, but the short answer is, in Emacs, each file has an extension, and you tell Emacs, when I load a file with this extension, use this mode. So when I open this file, which is .org mode, it puts me in a different mode. So I can do to-do lists, and I can actually do like full-on like Excel-style spreadsheets, right? Like name, title, XP. Oops. Okay, there we go. And now I've got a table, and I can do org-like things. So this is just built straight into Emacs. And now I can, Harvey, Remy, John, right? And I can actually treat this like a table. So that's all org mode because it's in Emacs. And this is the buffer I'm using is a .org file. Then I can switch the buffer to a code file, and it knows that a CPP file should be treated as a C style code. You're an Emacs user. Okay. Oh, that would be cool, but no, I didn't do that. Actually, there are there are things you can do in Emacs, which will let you jump to symbols. But yeah, I did not jump. I don't think they can jump you from org to something else. Okay, so you are an Emacs user. Good, good. Glamorous toolkit. I don't know if I know that one. I have let my Emacs foo get rusty. Multiple development experience. Okay, okay. Interesting reading for later. Yeah, so in Emacs, but in small talk. Oh, geez. Small talk. So my plan is I'm going to finish this game. Then we'll have a couple of weeks in between projects, main projects, where I go forth and rebuild my Emacs from scratch and both teach it and refresh my stale Emacs stuff. Okay, okay. Yeah, so I've got that searched up. Glamorous toolkit. I'll have to check that out. I was looking for something better. Emacs is really good except for like large files. It's really bad with large files. At least in Windows. Okay. So if you see all these pound defines and the if defs here, that's why. So this is going to make it hard to read. There is a hide if def mode, which we were just looking at, and I decided I didn't feel like fighting this on stream. So I'll figure it out over the weekend, and then maybe we'll be able to set up our file to read it easier. Okay, good. Always good to get another Emacs user in the chat. We gotta beat those Vim users, the heretics, the blasphemers. GT likes a good code editor for real. So you only like text editors that are not good text editors, huh? Emacs gets the same rap. It's a good operating system, but lacking a good text editor. Too funny. I want to say. Sorry, now I'm having doubts about a piece of code that we generated somewhere. Enum class. We don't care about the invalid reason a character exists. State ID. This should only exist in this case. So we need to wrap that in a pound define. This one, right here. It's got a cool, unique things and potential, though. Yeah. Yeah. I think to some degree I'm almost in the Jonathan Blow camp of all text editors suck, and if somebody would take it seriously, maybe we could get something better. But I just stick with Emacs. It's comfortable. I have the muscle memory. My pinky foo is very strong. But I am rusty. Not rusty. I've let my .emacs file like age. The bit rot is set in. So I probably need to refresh it between projects. Okay, so what was I even looking at? What are we working on? Oh, the for loop. Yeah. or while iterator is not at the end, get the character into the iterator, then we dispatch based on what our next state is, and it calls the correct function, which we emit here. So like that \s in a regular expression, usually it's just interpreted as space or tab, but since we support UTF-8, we can also handle non-breaking spaces. So there's a first character, it goes to state 2, but we munch the character in all these cases, we advance. We set the current rule ID so we know when we accept what rule we were on and how to respond. Like there's different actions. Sometimes an accept means to reject the token, like a comment token or a whitespace token, we just ignore it. Other ones, etc., etc. I've learned to use the palm for pressing Control and Shift. Interesting. Pinky internal knuckle. Well, all of the pinky problems got a lot better when I just remapped caps lock to Control. A lot less reaching that way. And it's right next to Shift too, so Shift Control is actually a lot more comfortable. But yeah, palming the Shift Control, that would work on some keyboards. Yeah, I could see that. Okay. So we got through the compilation actually. Which means what? So here we are in this loop. Where's my loop? Wow. There we go. Because we only want to advance. Oh. We only want to advance when we munch. So this for loop needs to go away actually. It needs to not advance. So find the while, here's the for. We do not want to advance it here. We're going to do nothing. That's only kind of true. Okay, well, we're not going to worry about that. So here we go. Okay, so those are all good. I just want to get to the point where I think I can fire this off and have it kind of work. So we're checking the code logically with just our brains and hoping that when we fire this off, it does something useful. Okay. It's all about the class tokenizer. So we need a context. States. Oh. Okay, there's the end of. Okay. Okay. So we need to do two things. We need the context. And then we need to load that into a tokenizer. So here's what we're going to do. We're going to go on a short restroom break and snack run. Snack run. I have some jalapeno poppers in the fridge calling my name. So get yourselves yourselves a drink, and I'll be back in just a minute. Okay, and we are back. So we're just going to continue trying to think through the problem. One piece at a time. So right now, Munch, I think, is probably fine. What I'm more worried about is accept. And accept needs to do things. Let's see. Okay, so this is that. This is that. So right now, accept doesn't do much. We can make it do something. So the token start character. Ooh. Start new token. So where is start new token used? Who's calling that? We define it there, we use it. There or there. Okay. So accept needs to call start new token, I think. Yeah. So everywhere we define accept, needs to start a new token. Two versions of accept because of the way that nested if statements have to go. All right. So into accept, and we're just going to stick with a function for now. We're going to create a stir rev from m_start or token start character inline. And our current character, and we do not want to include the last character. We actually want to rewind one character worth, which, if I remember, is a little bit complicated. Oh, no, it's actually not that bad. It's fine. Okay. We get a const char star text equals s dot c string printf token something or other, and there's no way we're getting this on the first try. Oh, I did goof up though. Yes, we did. We made these changes in the wrong place. start new token. Start a new token. Start a new token. Put this stuff in here. Okay. These are really good jalapeno poppers, though. Super tasty. Interesting. String reference. Public. So what's private here? Come on. Oh, not start character in line. Okay, that makes sense. Token start character. Token start line underscore token start character in line. Okay. That's closer. Some warnings. Okay. Okay, that actually is fair. Text is the last thing here. That's definitely what I meant to do. Nothing crazy about that. Okay. Let's see here. F5 to compile. No, I use F5 for edit keyboard macro. So, I don't have one defined right now. But if we did one that's like search for token, then change it to a brace, search for a square thing, brace, and F4, I can go to F5 and edit the macro to change its behavior as needed. Sometimes then I can run that macro with the changes and it does the thing. So I do use edit keyboard macro semi-often, and I can type the word compile pretty quick. Maybe I need to make compile F6. But I also like changing my compile. Let's see. Oops, what? rb.emax. Where do I define my f5? There it is. Which, yeah, that's that's a good point. I do this a lot. Why not? Like I said, this has all become very bit roddy. Okay, so we just come in here F6. Okay. Yeah. Okay. Yeah. So I do use that keyboard macro more often than I probably should. But so, for example, sometimes I'll create a macro and then I'll realize that to make it a little bit more flexible on the following lines, if I instead change a little bit, I can just go make those changes. Or I'll make changes with respect to one search term, then I'll want to do it for a different term, so I can go change it. Yep. Get some rest, sleep well, have a wonderful weekend. Hopefully we'll see you next week. Thanks for dropping in. Thanks for the questions. I'm going to have to retrain my muscle memory to go to F6. Okay. Sure. If we accept, we have not munched. Okay, I think that's generally true. If I munch, I don't accept. That shouldn't always be true. There are cases where we want it to. Let's see, is there a... Okay, well, I'll think about it. Are you making tabletop? In my spare time, I do a little bit of tabletop game design. I started one. The stream wasn't well attended, so on stream, stream wasn't well attended. So I was like, yeah, whatever. People tend to come for compilers, not for game design, which is a little odd, I thought, but whatever. But yeah, I've got a tabletop card game that has been play tested fairly enough that I think that the core rule set, the core mechanics and dynamics are good, really good, solid. Like it's a game I really want to play. I need to get the next batch of cards out, have them play tested, and start cleaning up and making the rules better. Like it's all kind of very fluid in the beginning when you first writing it. And the other thing is I have to write up setting stuff, and there's no art. I'm no artist. So there's a lot of work to do still on it, but I think the core mechanics and dynamics are really solid. I have another one, more of like a tabletop RPG game mechanic that I like. Well, yeah, more like combat mechanics. Maybe it's more of a dungeon crawler than an RPG system, but I really like it. Playtested once. I need to have a follow-up playtest with that group with better stuff. But then I've got like ideas for a tabletop skirmish game that I think is really cool. Another one for, yeah, I've got a lot of ideas. Too many ideas. Text documents full of ideas. So where we put out error, we probably should fix that. At least enough to... At least enough that I get a print out. Yeah. We should at least print something out. Print at... error. Error count. Ooh, do I want to do it that way? Kind of don't. Actually, here we go. Error count equals 0. Error. This is not how we will handle errors in the future, but there are. Error count plus plus. Is there anywhere else that errors happen? Nope. We should at least print out an error. Yeah, settings work, mechanics. I'm more of a mechanics and dynamics kind of guy. Theme is usually one of the last things to go on. I would probably greatly benefit from having an artist and a writer working with me, but one, two, okay. I can at least identify error states. Okay, I think we just wire this up to text then. Okay, text would be UTF-8. Our text buffer, fine. We want to work with this as a start point. We're going to create a context. It's going to reference the UTF-8 text. This right now that's the mode we're building in. Seems good. Set context to the context. Then what? This is obviously not the exposure we're going to end up with, but it's going to call process. Nope, stop me. Stop typing compile. I do need to retrain that muscle memory. It's gonna take a little while. Okay, so source builds db test parser. Okay, nothing's happening. Which means we're stuck in an infinite loop. Infinite loops, no good. Probably means we need to print more information. Jalapeno poppers went way too fast. No. We're going to kill that process. Okay. Printf. Oh, it's here. Char star temp equals underscore current dot c string. Delete temp. So instead of actually dispatching anything, just coming in here and force iteration underscore current munch. Will munch. You know what? Let's just keep it simple. Underscore current dot advance. Ugh. If defined, if defined, if defined, if defined, defined. Oh. Oh. There we go. Okay. Let's just see if we walk through the characters. Warnings. Oh. That's the reason we did that. Okay. Source builds debug UV test parser. It is not advancing. Why not? Why not? Hit the first letter, which is H, right? Because it's hello world. Print it out, fine. We delete our temporary string, and then advance. Used. I'm not confused. I'm just slow. I know what's going on. Right here. Oh wait, no. There's no fence there. We won't test it both ways. Source. Build debug. What? Huh. There it is. It's still not working. Why not? I changed. Oh. Oh, I changed it inside my generated text instead. Why? I don't know. I don't know why. Not cool. Okay. Okay. There we go. There's all my characters. Phew. Great. Now, we were doing that. I'd like to know what state I'm supposed to be in. Modulus D, which will be next state. Cast as an integer. Which should always be 0. So maybe that's not the most helpful. Go back to dispatching stuff. Oh my gosh. This is the problem. wrong definition in the wrong line, which means it's doing exactly what I did above. Ugh. Okay. If an assertion fails, why are you stack dumping? That doesn't make any sense to my brain. Clean and test. There's no stack because it's an assertion failure, but an assertion just ends the program. So why am I getting a stack dump after an assertion failed? Test parser 498. Line 498. Okay, well, a breakpoint didn't stop. Perfect. Nope, assertion stack dump. Okay then. Let's see here. Let's go to 1062. Breakpoint. $10.62. Run. Ah. Do we actually hit a breakpoint? Finally. Okay. Breakpoint is m_token start character. Holy moly. Why are we breaking at 14.99? That is not where I set that breakpoint. I set it at 10.62. What is going on? Okay. I tell it where the source files are. I say break on line 1062. I hit go, and it says, oh, I hit a breakpoint at 1499. I don't have a breakpoint at 1499. There's no such line as 1499. What is my debugger doing? Quit. All right, I'm gonna try. Maybe something else. Oh, it's not there. Where would it be? Users, downloads. Oh, put it on my desktop. Okay, hold on. We'll bring up a different debugger. And it did pop it up. Good. So we're going to file open I forget to double click. So active projects VV source builds debug this thing. Nope. Okay, so I don't want to open. Where's the thing? Add new target. Okay, we're going to delete this target. We're going to add a new target. That's what I was looking for. This one. Executable, working directory. Fine. Okay, we run it. Where's my output? Output. Call stack. Fails. But like, where are my outputs? Breakpoints plus a what? Where's the add? Breakpoint. F1. Breakpoints. Oh look, there it is. But I already had one of those open. How do I add a breakpoint? Disassembly. Okay, maybe. Oh, maybe no. have added a breakpoint to this before, so how did I do it? So my debuggers are useless. That's always good to know. And I want to add which less. Let's just add the view, not sorted alphabetically. This assembly helps me not at all. Unbelievable. Okay, well. So lame. Okay, so I can't put a breakpoint anywhere to watch my values. Scan, yes, we're still working on a Tokenizer Generator, and my debugger is buggered. Started a new debugger right here. Fired it up. Tell it where the source directory is. Tell it to put a breakpoint on 1062. Run it. And it's like, hey, we hit a breakpoint on a line of code that does not exist. $14.99 isn't even in the file. There's no such line. Now I'm just confused. If the debugger won't break on the right line, I can't really debug this very well. Which makes me sad. Google GDB breakpoint stopping at wrong line. Did I not disable all optimizations? Maybe I didn't. Pardon me. There we go. Source. File. When I build a test, debug flags, I do turn off all of those. Guess that's not the problem. Ugh. All right, so how to debug? Setting assertion. and failing, and I know where, in theory, although is this a line number? It's not a line number. 498 makes sense. We test parser. 498. This is where we assert the character is valid, but I can't put a breakpoint here. Or apparently here. I'm going to pull clean and build, so we shouldn't have any out-of-date binary pieces lying about. No partially compiled or intermediate states. Assertion failed. And then it blows up. Unbelievable. New string from somewhere to somewhere plus something. Which would be token start character dot byte offset. To current dot byte offset. Okay. Error 1. Which at least tells me letter H. Actually, huh. Okay, let's go to our toke test.vtoke. Make this more complicated. Let's take out the character for now. It's hard to debug when your debugger lies to you. Oh, if we get an error, we munch. Maybe that would be a useful thing to put in. Error. Modulus D. Bunch. Then what? Might help a little bit. It's not going to hang on at the first error it hits. At least move on. Let's debug VB test parser. Okay. Begin 0 to 5. Okay, so let's see here. What do we even have here? We have from 0 to 5, which is the word hello. We have a space from 5 to 6, so one character. Then we get a Greek letter, which is 2 bytes, which should go 6 to 8. Then we should get an error, which needs a new line character. We should get a space from 8 to 10, 8, 9, 10, yep. And then world from 10 to 5. 2, 3, 4, 5, 6, 7, 8. Oh, 8. This is in bytes, not characters. 10 to 15, and then an error. And then we're done. Okay, so this actually is coming together a little bit. Okay. Let me think. I think if you error out, you could also start new token. Kill token's ruined, right? Right. We munch, then we start. doesn't add syntax for now. We're going to keep syntax, which will be one of comma, period, exclamation mark. Just for now. It doesn't really matter. Alright, so compile this. We shouldn't get any errors. Okay. 0 through 5, 5 through 6, 6 through 8, 8 through 9, 9 through 10, 10 through 15, and end. Okay. Now, the question becomes, those characters look correct. So why, oh why, was that blowing up? See, it just blows up. And I can't attach the debugger in any meaningful way. Source directory, breakpoint, dd, test parser, .cpp line. Line something or other. Oh. Accept. So where did it say the line was on? 198. This one. It says it's blowing up here on an assert. Usually an assert executes and it says system exits. I can't put a breakpoint here. 498. I can't put a breakpoint here. 1072. 1072. Where I actually instantiate the string reference. Now, when we run it, it hits a breakpoint somewhere that doesn't exist. It only goes to 1200 lines, not 1499. A vector clear. I can't print anything useful here. Hit breakpoint 2. Token, allocator, token, clear. This is our vector. We're calling clear. So it's the context. Test.cpp line what? 740? Oh my gosh. Okay, well that's terrible. Okay, well, at least it's giving me a normal class name now. It's a positive memory address. It's not showing one of those standard patterns I would see in a debugger, like fee, or zeros for null. This is a pointer to a context, which has the same address as the tokens. The address of my tokens. Oh, not quite. There's an offset. Okay, good. Up. We're inside tokenizer process. $980. Okay, at least it matches with this. Context is null. We set the context. Clear the tokens. Clear, pushback, or return. Clear, and tokens. There's nothing weird about this. We can remove that from our tokenizer. I'd be skeptical if that fixes anything, because it wasn't a problem in the first place. Unless I'm really missing something that I'm really missing. Up, or up. Yeah, it's not running. Okay. This is a little bit absurd. My compiler and debugger are lying to me. Source. Set the breakpoint. No line. And 72. Oops. Don't need to do that, so that's fine. Well, fine, we'll just run it. It's failing the assertion. Breakpoint DB test parser.cpp line 10 72. Oh my gosh. What's going on? We run it, it blows up on the assertion and then does a stack dump, which it shouldn't do after an assertion. Well, it's okay, so the stack dump is happening because of this. Invalid access on first error. But this works fine. Hey, FitWriter, how's my weekend going? Well, we're working happily on compilers, and now we're fighting our compiler and debugger. Somebody's lying to somebody. So that iterates just fine. I mean, we can get more information if we want to from here to here. How are you doing there, FitWriter? What's new? Weekend hasn't started for me yet, but plan to have a pretty quiet one. Maybe do a little bit of woodworking, nothing too crazy. Got a comma. Gonna grill up some steaks tonight. Planning to go to range. Am I going to the range? No, I'm not going to the range. I think I might go camping next week, and so maybe I'll bring a toy or two. Zero has 0 bytes. Okay, that actually could be a problem. That actually might be the problem. So this 2-byte one is the omega from the Greek alphabet in our test string. Character 0 should be the capital letter H. So here's the test string, which we probably should print out. Backslash quote, there we go. Quote of whatever text we chose. What about you? Have you made it across the border to go do a little shooting? I think we said you were within striking distance of. So 0 is H, and byte count is 0. I'm a little bit curious about how that could happen. Text buffer. A character being given a buffer. Oh, we hide those initializers. No, we don't. We use this one. Set buffer buff. Set buffer. Buffer equals those things, byte offset, character offset. Then we do an update. Update. So take a byte count here. That should be done right there. Okay, is there something in a assignment operator? Byte count is copied. Huh. Wait a second. Start new token. Not worried about that one just yet. This one. Our new token starts before we get our first character here. Oh wow, okay, ham underscore current. Which means literally this could just be a while loop. Um, Okay. There we go. There's one byte. Now it might not fail because this is actually initialized first character. Okay. Therefore, tokenizer right here. We can take, we'll leave that on. That's fine. 1, 2, 3, 4. It does get hard to debug with all of the pound define if defs, so that is a thing I will have to do offline. Is figure out how to get my Emacs to do it right. Okay. Well, that is not right. This new token. But we're on the right path, I think, and therefore oof. Okay. So there's token 0, 0, hello. We move advance 5, we get a space. That's token line 0, character 6, which is omega, which is a 2-byte character. Token at line 0, character 7, comma, space, world, the end. Okay. Whew. All right, we're making progress. Finally past that thing, whatever that is. Okay, so at least fake tokens now. Ooh, line. The other thing I want to know is current rule ID. I don't think I actually use token ID at all. So I should be able to. Ooh. Okay. I think we're close to where we need to be. Okay, so we have a tokenizer. I mean, starting one. We have that's not vtoken. So we have the word hello, which it tells me is rule 4. So 0, 1, 2, 3, 4. This rule. It's an English letter token. Then we get a space, which is line 1, correct. Then we get an omega, which is from the Greek letters. So that should be rule 6, 0, 1, 2, 3, 4, 5, 6. Yep. So there's token 6 from rule 6. A comma, which is syntax. A space, back to rule 1. World, which is another English word. We do not get the exclamation mark because we started the token, but when we hit the end of the loop, it does not accept. So I think we just need to fix that. So if we put literally any other character at the end of our test string, so let's say go to that's not CPP. If we come in here and if we put like new line in here, we would get that last syntax piece. Oh, what? Something break. Oh. Well, that's odd. Text does not have the backslash n I put in there. Oh. I know why. It's the Latin one. We need to do UTF-8. So it'll put out the exclamation mark, but not the new line. That's what's going on. Boom. Bang. You have an error 1 in the... Well, that's interesting. Error 1. Test parser. So that is in DFAStates 0. It's \n, not in my list. How is that not? Oh dear, so let's check. I know I'm outputting the table in the compilation here. So where's \n? It's 3? Why is that state 3? \n is not in state 0 somehow. Well, that's a little bit awkward. Put a dot. All right, comment. So the new line character is not found in state 0, which should be impossible in my opinion. So we have to look at that one of these days. Yeah, so it goes not to the last one. So tokenizer at the end of this loop. Not accept. I want it in the loop, right? Here, we dispatch on the switch. We break out of the while loop, or the other while loop. If m underscore token start character is not equal to m underscore current. So we're not at the end of the string. Then we can accept one more time. Tokenize the trailing characters. This may not be entirely valid or correct. Oh. I'm wondering, how did I do that before? I have old code here. Let's go look at an old one. Either core. Unwieldy parse. Tokenizer. Parse root. Blah blah blah. If token rule ID is greater than or equal to C. Okay. That is probably fine. If and I think we call it current rule ID these days. Okay. I think that means you might be able to fudge a weird character at the very end of your file and have it not fail and give you a weird token, but you'd have to really kind of know what you're doing to end up there. It did not pick up the trailing comma. So why? Switch. Nope. When I start a new token, that's a good question. Oh, well, this is probably not correct either. So if it is valid, there we go. Because we could be at the end of the buffer. The last character in our buffer may have just been a weird one, but we didn't get to process it fully. If it's valid, and if our current rule ID is greater than 0. Let's try that. How about it's not testing those two as equivalent because the values aren't. Equal doesn't mean that necessarily what I think it should mean necessarily. Or it's useful in some cases, but not in others. Oh, okay. We're back to weird things. we were printing out other things. So let's hope Tokenizer. Just put it back in. I love reach and undo. It's such good stuff. So nice. Huh. Well, what the dickens? I'd like to see this state, please. Oops. Not there. Tokenizer. Huh. New string 16.1, 16.1. Oh. The character itself was never dereferenced because of the while loop. I think that's the problem here. For each. How about this? Here are my two while loops. What if we just don't do that? Munch. If we're in a for each. M underscore current equals the contents of M underscore iter. That much doesn't need it. This much does. This one does not. Okay. That'll give us a string reference of like 0, which is a problem. So this might fix that. There we go. Boom. We got the X and we're done. Phew. Okay. Not too shabby. So we are actually tokenizing this. Each of these is the string. We know what line it starts on. We know what character on the line it starts in. We know how long it is. And we know that it's rule number 4 that's accepting, and rule number 1 that's accepting. rule number 6. So we can actually build out the rest of this nonsense. What we need is a table of accept actions. Depending on which state we accept from. Yes, okay. All right, let's comment out that one. Tokenizer.cpp. This is just too handy to delete. Useful for testing iteration problems. Not making a token. This shows we have everything we need. What's the other thing we need? We need to know how many characters the token is. So line, whatever, modulus d characters long. So m underscore, no, s dot, string reference, UTF-8. What do we call it? Byte count, char count, char count. That's really the only other thing we need to talk about. Which means our regular expressions are working, except in the cases where it's actually generating the wrong DFA table, but we'll have to fix that in a minute. Boom, run. Hello, 5 characters, there's a single space. There's an omega, 1 character, but it is 2 bytes. I don't know why we used a period there, not a colon. Comma, space, world, 5 characters. Boom. Okay, let's clean this up just a tiny bit. Let's see. Clean that up. Tokenizer. I'm just gonna make that a colon. That's fairly standard procedure, I think. Line whatever, character whatever. Rule ID. Put rule ID last. Okay, so now we can look at the entire core DFA regular expression processing loop. There we go. So, hello, 5 characters for rule 4. Character for 1, 6 is the Greek letter. Rule 7 for syntax. White space is 1. World is a rule 4. Okay. I think that's a good place to save our work, at least. Sure. Okay, there's still loose ends, but the overall flow for this combination of processors, of performance switches, is more or less functional. Beginning of first processing loop. Basic processing loop complete for set of process batch text for each dispatch on a switch. This means we iterate through the text file and correctly identify tokens, all information to accept a token. The token is not actually created or discarded. Let's hear. No rule actions are taken. No tokens are created. In our to-do, this is going to have to be addressed very soon. Some regexes generate wrong DFAs. \n found in start state. String pattern fails, which would look like a quote followed by a quote followed by anything which is not a quote, or I think this just is true. Let me go do test.db string keep. That's a pattern. With a star, you can't have an empty string. This is not quite right, but let's go ahead and run it real quick just to test. All right, let's save this for now. If I remember right, capturing a string does not give me the right DFA either. I would expect string to go to state 7. Anything which is not a string goes back to 7. Oh, it is working. And anything which is an end quote goes to state 8, which is a straight up executing state. So what does state 8 look like in here? 008. Right here. It just accepts. Yeah. Okay, so that's odd. Why did that work all of a sudden? It didn't work last week at one point. That's good. Make this slightly better than test CPP. No, test VB. I'm going to put an example in my journal to debug. We need either one of those, or backslash followed by any character. Maybe that's more correct. I wanted to try this first, actually. I wanted to try backslash dot or anything which is not a quote. I don't know, let's try it. That generates the correct DFA. We built our code, running our own project, and it fails out. That's not V code. Oh, missing a terminating character. So let's go fix that. That's causing issues. Go to project. Okay, so it's a backslash right. Oh, maybe that would do it. Off to deal with broke down vehicles, always fun. Have a good evening. You too, have a wonderful evening and a great weekend. We'll see you around. Thanks for dropping in. Okay, so now, come in here. String, go to 7. We include a backslash quote. That's not quite right, is it? Oh, no. Fusion. Let's see what it put in for state 7. Okay. Look at another quote. We go to 8, which is accepting. Fine. Exclusion, anything which is not a backslash or a quote. We come back here. So the only question is this. Just because this is logging out wrong doesn't necessarily mean it's actually wrong. So let's go check. Because, yeah, those aren't necessarily logging correctly. So it's a whole item we need to address sometime. If we get a backslash, we use it up and go to 10. If this is equal to a quote, we munch it up, otherwise error. Oh, so that's actually bad. That should not be an error. So let's go back to test.vtoke. Okay. I know there was something goofy about the way a string processed out, so hopefully this just fixes it. And it fails. So it's not v token. So this is indeed wrong. So backslash anything or journal no, not journal view. Make this two different items. New line pattern not found in start state. String pattern fails and some variations such as quote a backslash and then a quote or anything which is not a quote. So if we got a backslash anything else, that should just about work. Okay, well, we've got to fix those eventually anyways, so. Okay. Regex patterns don't filthy right DFA added to do in other words. I know what EG means. What is IE? It's id est. That is, as in that is to say, or in other words, okay, yeah, id est. Good old Latin. EG is exempli gratis, which means free example. Okay. Let's go in here. Let's. Oh, another thing we need to do. Doc metrics in. Oh, we do blacklist code snippets. Good. I don't consider that real code yet. Like, it doesn't count toward the line count. There we go. Right. processing loop kind of works. See journal for details. Okay. All right, so it would be the best thing ever if we stop doing this and start doing the right thing. Which means I need a rule table. And the macro for accept is going to become a little bit painful. So we have to start a new token. We have to set the next state back to the beginning. Okay, so we need that. We really don't need this anymore, but we do need starting line, starting character in line. These are all useful variables to have. We need that token. It's constructed with line, character in line, string reference, and an ID. Which should give me everything I need to compute the current token ID. These are the things we need to create our token. As a token constructed from here looks like this. We can have the string ref, the line, character in the line, and the ID, which we can derive from the rule. Why do we even have this in here? I don't think we need it anywhere. Okay. So what we need is, I guess, a dot, dot, dot. I'm sensing some hesitation on my part. How do I feel about that? Do the switch. This happens once per token. Once per token. Think about. Because there's different ways we could do this. Oh, good heavens. Any other nuts after this? There is. That's when we do the method definitions. So Tokenizer now has a new chunk, and something has to be outputted before the method definition. So VB project. Here. This goes here, and then writer point to, let's see, write, accept cases. Writer, and then blank line. Function cases. Pretty sure that's a thing we have to do. DFAState methods. DFA switch. Okay. For each rule in our DFA, basically this. Case. I want the state ID. I want the rule ID. Who has that? Is my tokenizer definition? I have the rules here. Perfect. We just expose that. Rules. Ooh, and tokenizer definition. Underscore rules. Okay, then VB project. Tokenizer rule in m underscore tokenizer definition rules. Doesn't really have any kind of enumeration for rule numbers. This is just the rule number, right? Later on, these state numbers are going to get more complicated when we start adding new features to our tokenizer. But for now, they could be a number, but I already know ahead of time that we're going to do something more crazy than this. So this can be a number, though, because it's a rule. Is that true? I'll write myself a to-do. To-do. Possibly enum class. Enum class instead of int. It's not the worst idea. The way I did it in the other program was I always got a different function for each chunk of things we were doing. Putting it all in one place might not be that bad. Might be, well, it would be easier to track. It'll be fine. So we're gonna put a case of a number. Rule point to tokenizer rule. Pretty sure it's just called rule ID. Rule ID. What depth are we at here? Tokenizer. Depth of 3. Okay. So now put something like that. Okay, so the break is indented. Case thing and break. See how it looks. Oh. That's right. It's not a pointer thing. We own it. We have it in the stack. Forgot about that. That's okay. So let's go back to it failed. Oh well. Let's take the string out. Rerun it. No. Whoa. What? Oh. Probably got some of our statements in the wrong places. So let's go to m_current rule ID to enum class. I kind of like it. Okay. Thinking this through, we go to Tokenizer. Below this line, I wonder, in my codes, in my tools, embed code snippets, search for ... If I not strip dot starts with okay. If the line starts with ... So that means I can do things like this. State ID enumeration end of chunk 0, chunk 1. End of chunk 2. Dispatch DFA by switch case. End of chunk 3. Except based on current rule ID. End of chunk 4. DFAStates as methods. And well, let's just search chunk 1, 2, 3, 4. Okay. So with that in place, we at least know what chunks we're looking at, and we could do fancier things here. But I bet a large part of the problem is this. But adding some notes to the divider is a good idea. Okay, that worked better. B test parser. Oh, here's the accept. Next state goes back to the beginning. We have case 0, 1, 2, 3, 4, 5, 6, 7. Seems reasonable. That break should have. Oh, I know what's going on. Okay, that's fine. Pop break. Okay, for each rule, we have to do the right things. So what's an AVB tokenizer rule? Well, we need to know what actions we can do. And this is not the best way to get at these actions. Let's add a note to our to-do list. VP tokenizer rule stores actions as string. Make some flags. Okay, we're not gonna do that right now. This is the problem when I only work on it once a week. Like, I kind of have to pick and choose what I'm gonna tackle. So, VB project. Star actions equals rule to actions. Now those actions what are all the actions we accept? Keep, discard, new line. Is that it? X is discard, K is keep, L is new line. So that's it, I guess. Alright, let's just do this here. It's not great. Do project. Okay. Make some flags. CBB project. So we're going to step out what will need to be done over there and just not do it correctly here. If we're going to do it here incorrectly, might as well do it there correctly. It's not any more work. Yeah. Let's not do it this way at all. We don't want to expose the actions. We want to say bool do new line. Bool do keep or do discard. Right after regex. We're not exposing these actions. Okay. Do new line. For char star C equals underscore actions C not equal to the new line character, the empty character plus C equals false. If C equals a new line character, or what do they call it? L line character. Result equals true and break. And done. Much the same thing here. We're going to say keep as default. If it's k, result equals true. Else if c equals discard, result equals false. So what this means is in here, in VV tokenizer, in STV token, you can have x, k, x. It's only the last one that matters. That's all this means. So we start with the default of true. If we see a k, we go to true. If we see an x, we go to false. So we can have an x followed by a k, and it's the same thing as not having the x, or vice versa. And basically, the same thing here, except the default is flip. If by default we do not discard, do we need to do discard? I don't think we need it. Yeah, we don't need this. That's useless. Yeah, easy. Okay, now back to VV project. If rule dot or do new line, we'll output some code. If rule do keep, we output some code. Oh, do not output code. Like rejecting or discarding a token is as simple as doing nothing. So if we do new line, I think all we do is, we have to output this after keeping, is we called it something clever, tokenizer, we called it new line. Nice. If do keep, we have options here. Keeping our token, it depends on which state we're doing. So if we go to our performance switches, process batch, if def process batch, process lazy, to do implement. We are not doing lazy today. We're only doing batch. So if we're in a batch, then we take context or underscore context to add token of token of stir ref just did this, didn't we? This thing. This is our text, add token of token text. Start line. Character line. And not the current rule ID, but rather the rule point to token ID. I want to make this all a single line. There's no reason to not. Like, we're not writing code to be human readable here, so simplifying is not bad. All right, let's try that. Just see how it behaves. Oh, okay, so we need to still expose actions, so that's fine. Tokenizer rule. Put it back. That's why I'm really complicated. I thought we might have to do that. If it wasn't needed for output, I wouldn't worry about it, but we need it for output. Like if there was just something stupid that was using it, we could have gotten rid of it, but it's for output purposes, so it's fine. Okay. Here we go. Token int. That one. That says code snippets. Token C int ID. It needs the ID, token ID from the thing. Okay. Which we generate somewhere. Token names at the index. Yeah. So actually this is modulus S. Token names at the token ID. Ooh, so close. Token ID was not declared in this scope. What? Oh, okay, because token ID should probably scope it, that might help. Okay, getting there. Expected something before break. Case for if process batch in context add token. We need to put a semicolon at the end of that. Might help some. Okay. What else we got going on here? We needed another parentheses. Okay, yeah, one more print. Okay. So we process tokenizer.cpp. We're in batch mode, process, and oh, we're not returning our thing. Interesting. I don't know if this is, yeah, probably not. Okay. At the end of batch, here, void tokens, and it's not void. We don't type it in. It's XYZ m underscore tokens. Oh no, the context has the tokens. That's why we deleted it from here. Okay. Okay, then in here, context dot we have our list of tokens. Clear, add, and there's the tokens. Okay, we call it that. For ED test parser token, token in tokens. What do we make available? Token at line, character, and ID string. Tokens sum number, which is context dot tokens dot size. Token line thing character thing line token dot line char inline and token dot ID string. Okay, so in theory, this should not print out the ones that we want to skip. And it should only show the ones that actually we want to keep. Oh, it compiled. That's always promising. And it dies. Processing begin, and it croaks. Probably in accept, but why? 5:30, darn it. We're so close, so close. I do not want to go too late as my stakes are calling to me. I do want to get this last little piece done here. We no longer need this. Okay. I suspect it has to do with our accept function. Accept 4, accept 1, accept 6. So do this. And then actually look at what we're generating. Maybe we're doing something terribly, horribly wrong. Or it's succeeding on all of the... No. Yeah. 416. Let's look at test.vb toke. 4 1 0 1 2 3 4 5 6. Oh, 4 1 1 6. Okay, let's look at what we've got here. Go to VB test parser. It's just printing out the new line. That's it. Oh, no, these are all just pass-throughs. One is a discard. Four, 5, 6. So 6 worked. If process batch, add a token, blah, 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 blah. 4 worked. Doesn't look to me like it's doing anything differently than what we were logging before. What do about that? Six is a token ID as well. It's, I think, we'll make a character. 2-byte character. That doesn't change anything, but it makes it a little bit easier to read. Start line, start character in line, token ID, whatever. Doesn't change anything, so it's still gonna fail. But the question is, why is it failing? Okay. Tokenizer. I'm gonna put this back in. As we can. Hoping in the next 15 minutes to fix this last little issue. Six, 2, 8, 1. There is no way that my debugger is going to behave any better today, is it? Okay. Start line, start character in line. And token ID. See this? This looks nothing different from 4. These are doing the same exact thing. So what happens in 6? It is so different. If I put a break here, break at 11:18, GP dash args source breakpoint test parser.cpp at line 1118. Run. Oh, it did hit a breakpoint. What was my debugger doing earlier? I do not know. Or start a token start char. What? At 11:89, it didn't break at the right point. We're back to that fun games. Current rule ID equals 5. Next, munch. Okay, so we accept whatever it is. We go to 7. And then it doesn't know what to do. This is freaking ridiculous. The symbol table is totally borked in whatever the debugger's putting out. Makes me sad. You have to do it the hard way. The new token from here to there. Line thing, character thing. token start line, token start char inline. Using rule number thing, current rule ID. Okay. This is useless. Oh, we might as well just run it then. Continue. New token. Line 0, character 0, rule 4. Line 0, character 5, which tracks by rule 1. Line 0, character 6, by rule 6. This has before turned out useful things. Okay, could it be string reference from token start character to our current character? Char start temp equals s c string delete temp temp. Okay. Just looking for anything out of the ordinary that I don't like. All right, new token. Here, hello, which is rule 4. Rule 1, we accept rule 1. It's a space, which should do nothing. New token thing 6. All right. Possibility number 1 is that it's not properly copying because there isn't an actual instance, and I don't have a move semantic defined. So maybe BD project is fine. If do keep, oh wait, here we go. This actually just comes down here. Else you know what? Let's just scope protect every case statement. I think that's easier. Right. Okay. Still crashing. That's fine. Well, the test parser.cpp. Six. Yeah, I don't want that there. Actually, oh, okay. Hold on, token. Okay, well, that's fine. String ref stir. So we're creating a small scope. Copy paste and copy constructors. Ooh, is that a thing? String ref. There's a copy constructor and there's an assignment. Okay. Boom, still dying. Okay, my debugger hating me is not helping. It probably has to do with all those if defs we have. We're so close though, so close. I can feel it. I guess you can't put a breakpoint at the right point. Adding token. Maybe it has to do with this chunk here. Wait a minute. What is token? Oh, the text. Name underscore text point to C string. ID string, text string. We don't need to do this. Adding token, modulus s, token point to ID string. So that's a static thing. Text string is generated. We must then delete the text string. Context. Want it so that today there's one path through the code which generates our tokens. What? Oh. Sheesh. Okay. Adding token null. We're getting a null. Oh my. Okay, well that's indicative. We have the string. Why are we adding a token? Adding a token. I don't think that should be printing what it's printing. We accepting rule 4, we add a token, and it's just wrong. So in ID string, ID index, it's ID index, static cast the ID to an integer, stop. Class token. Our token has these IDs. White space. And the map has those 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. Huh. I am confused, and I need to use the restroom, and I'm running out of time. Okay, We're gonna pause for just a moment for a restroom break, and I'm gonna see if I can finish this in like the last 10 minutes. So, just a moment. Okay, we're back. Push back a token. We need to go to here. Token, given the string, all this stuff. What? Oh, capital V? No. Okay, this is ridiculous. It's junk. You failed me. Token ID. Something before add token. Did I forget those? Okay. I think we're super close. Like, there's just one thing, but the debugger won't show me what's going on. It's crashing in weird places. Adding token. Null. A point there. I would really breakpoint here. So far, it's not been successful today because it keeps doing weird things. So breakpoint test parser.cpp at line 746. 746. Run. It hit a breakpoint, but not where I set it. 746. Right? So what's it say 812 for? And it doesn't know the file, so sheesh. So what's it doing at 812? I don't know what it's doing at 812. What does it think it's doing at 812? 812 is nowhere near. This is just random. We're not even doing this. This isn't even a thing we do anymore right now in our run. No, I would like to know what that number is. What was it got? Okay, adding token. Oh. In context. ID index. Is it like a -1 or something? But then the question becomes why? Adding token 3. Why is 6? So these are valid indices. Enum class static const ID to string map. Zero, 1, 2, 3. Oh. Oh. And yet this is compiled this whole time. Okay. Oh goodness. Alright, so let's just go back to this ID string. Then we need to get a VV project. ID, let's see here. What is it even called? Token. I don't know what's it even called. Token ID. Huh. Writing it somewhere. That logic was inverted, and that's our only problem. Then that's just a little silly, but it could explain some of the behaviors we're seeing, but maybe not all of them. Okay. Adding token ID, hello. So that is now correct at least, but it's still crashing for other reasons. Dumping stack trace, I mean, I've looked at these before. They're almost useless. Frame, function, args, like, none of this is useful. Loaded modules, yes, I know all the DLLs. I don't know them, I just function. Now, GDB load stack dump. No. GDB path to the binary, path to the core. GDB path to the binary, so source builds debug db test parser and db test parser stack dump. Reading symbols, it's not a core dump. File format not recognized. Using msys. Huh. This is Sigwin. What about msys? Msys 2. Unbelievable. So what is this stack dump even doing? What is this? It's not a file format that's recognized. It says it's dumping one, but it's not usable. Which GDB? Oh, quick. Which GDB? Okay, let me look real quick. See, msys. Like user bin. GDBM dump load. So this doesn't have GDB alone in user bin. What about in like opt bin? No opt bin. Dev. No. It's not Nancy. That doesn't make any sense. GDB. Well, alright, I'm running out of time. I gotta go make some steaks. That makes me sad. Which means... what? Do I debug this off stream? I don't like getting stuck over the weekend, but I'm trying to do everything on stream. Anyways, I'll think about it. Thanks for joining. I'm gonna wrap it up. I'm gonna go eat some dinner. Have a wonderful evening. Thanks for dropping in. Glad to have you here for the ride, even if we don't quite end at the point where I want to. Yeah, I think that's it. Have a wonderful weekend, and we'll see you on the flip side. Bye-bye.